Hi there. In this lesson, we're going to talk about the half-angle formulas. So these are formulas that we can use to find the sine, cosine, or tangent of half an angle in terms of trig values of an angle. So we're going to start out by looking at these formulas here. So these were our power reduction formulas for sine and cosine. So this was a way to express sine squared theta in terms of cosine theta and to express cosine squared theta in terms of cosine 2 theta. So what we can do with this is perform a substitution where instead of thinking about theta, we're going to let alpha be some angle, and theta is going to be the angle alpha over 2. So then what will happen in our formulas, instead of having sine squared theta, we're going to have sine squared of alpha over 2. And instead of having cosine 2 theta, we're going to have cosine alpha, since 2 times alpha over 2 is alpha. Similarly over here in the cosine squared power reduction formula, we'll have cosine squared of alpha over 2 is 1 plus cosine of alpha divided by 2. Okay, so all I've done here is, instead of using the angle theta, I'm using the angle alpha divided by 2. Now what this allows us to do is solve for sine or cosine of alpha over 2 by taking the square root of both sides. So we do this for the sine squared. We take the square root of both sides. We're going to get the formula sine of alpha over 2 equals, and we're taking square roots, so this is going to be plus or minus. We're essentially solving for sine of alpha over 2 by taking plus or minus the square root. Okay, and we'll get the formula sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. Similarly, the cosine of alpha over 2 is plus or minus the square root of 1 plus cosine alpha divided by 2. Okay, so these are going to be our half-angle formulas for sine and cosine. So this is the half-angle formula for sine. This is the half-angle formula for cosine. Now when we do the half-angle formulas for sine and cosine, note that there's a choice to be made. There's a positive square root and a negative square root. The choice of plus or minus is going to depend on whether the sine of alpha over 2 or the cosine of alpha over 2 are positive or negative. So in other words, the choice of plus or minus square root is going to depend on what quadrant alpha over 2 is in. Because that is the angle that we're trying to find the sine or cosine of. So if alpha over 2 is in the first or second quadrant, the sine is going to be positive square root. If it's in the third or fourth quadrant, we're going to take the negative square root. For cosine, if alpha over 2 is in the first or fourth quadrant, we're going to take the positive square root. If it's in the second or third quadrant, we're going to take the negative square root. Okay, so again, the positive square root for the sine is going to be if alpha over 2 is in quadrants 1 or 2, take the negative square root. If we're in quadrants 3 or 4. Okay, and then for the cosine, we would take the positive square root if we're in quadrants 1 or 4, and we would take the negative square root if we're in quadrants 2 or 3. Okay, in addition, there is half-angle formulas for the tangent. And there are a couple different ways that we can do the half-angle formulas for tangent. The first would be to just do the sine and the cosine formulas and divide them. So do sine of alpha over 2 over cosine of alpha over 2. And when we do that, we get that tangent of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Okay, and again, the choice of plus or minus is going to depend on the quadrant of alpha over 2. We take the positive square root if alpha over 2 is in quadrant 1 or 3, take the negative square root if we're in quadrants 2 or 4. We can also use conjugates, or we can use the power reduction formula for tangent in order to get a couple other alternative half-angle formulas for tangent. So one of them is 1 minus cosine alpha over sine alpha. The other one is sine alpha over 1 plus cosine alpha. Okay, so I won't go through the derivations of those two formulas, but these are some other ways that we can express the tangent of half an angle. For my money, for most applications, I prefer this half-angle formula for tangent, 1 minus cosine alpha over sine alpha. It has the drawback of we need to get the cosine and the sine of alpha, whereas the first formula we only need to find the cosine. But it has an advantage of, first off, both of these formulas don't have a plus or minus. So the nice thing about these two formulas is it will detect what quadrant alpha over 2 is in, and it will assign the plus or minus sign automatically. So there's no choice to make. It's going to pop out the correct plus or minus sign depending on the quadrant of alpha over 2, which is really nice. The reason why I like this second formula a little better is because it has just one term in the denominator, so it makes the arithmetic a little bit easier. Okay, so at this point I would recommend that you take a screenshot or pull up a formula sheet, pause the video for a moment, make sure you have a copy of these formulas because I'm going to erase them so that we have room on the board, and I'll work through some examples using these formulas. Okay, so just like when we were doing a lot of our other formula problems, there are two types of examples we're going to look at. We're going to look at examples that have numerical angles, where we're trying to find the trig value of a specific angle using the formula. And then there are also going to be problems where we're going to be given information about the angle, a quadrant, and one trig value, and we'll try to find sine, cosine, tangent of half of that angle. Okay, so to start out, let's suppose we wanted to find the cosine of 165 degrees. Okay, so one thing that I will point out, for a lot of these problems, if I ask you to find like the cosine of, say, 75 degrees or 165 degrees or what have you, often there are a couple different ways to do the problem. Like you can often use a sum or difference formula, or you could use a half angle formula. That means I need to tell you which formula to use on an exam, because depending on which formula you use, you can get examples or problems that look different. So the answers will be slightly different looking, but they will come out to be the same number, just depending on which formula you use, a sum or difference versus a half angle formula. In particular, with half angle formulas, you'll often end up with square roots inside square roots, whereas with a sum or difference formula, you wouldn't have that. And the answers will look very different, but numerically, if you put them into a calculator, they'll actually be the same. So as to eliminate any sort of confusion, again, on an exam, I would say use a sum or difference formula or use a half angle formula to evaluate this. Okay, so if we use a half angle formula, we can use the fact that 165 degrees is 1/2 of 330 degrees. Okay, now I'm going to leave the plus or minus for just a moment, and I'll use the other part of the formula, and then we'll go back and figure out if we want a plus or a minus square root. Okay, so using our half angle formula for cosine, this is going to be either plus or minus the square root of 1 plus the cosine of 330 degrees divided by 2. So again, let's put a box here because we need to figure out if this is going to be a plus or a minus. So this is just the half angle formula for cosine. Cosine alpha over 2 is plus or minus the square root of 1 plus cosine alpha over 2. Now to figure out if this is a plus or a minus, we want to look at the angle we're actually trying to find the cosine of. That's 165 degrees. Okay, well 165 degrees is between 90 and 180 degrees. Okay, it's in quadrant 2 because it's 180 minus 15 degrees. Okay, and therefore the cosine of 165 degrees is negative. And therefore we use the negative square root. Okay, so note we are not using this 330 degrees to figure out if it's a plus or minus square root. 330 degrees is in the fourth quadrant, but the decision of plus or minus square root falls on what the angle is that we're actually trying to find the cosine of using the formula. Okay, so in this case it's going to be negative the square root of 1 plus the cosine of 330 degrees over 2. Okay, so that's going to be negative the square root of 1 plus cosine of 330 degrees is square root of 3 over 2 divided by 2. Okay, so here 330 degrees is in the fourth quadrant. Our reference angle is 30 degrees. Okay, so now we want to simplify this. And what I will do to clear out fractions is multiply the top by 2, the bottom by 2. Okay, and that's going to clear out that 2 in the denominator of root 3 over 2. Okay, so this is going to be negative the square root of, we distribute through the multiplication by 2, we get 2 plus square root of 3 up top, 4 on the bottom. And then finally we can simplify a bit. We can take the square root of the top, which is the square root of 2 plus square root of 3. On the bottom we have a square root of 4, which is 2. Okay, so that would be the answer we'd get using a half angle formula. As like I said, for a lot of the half angle formula problems, you will often get these nested square roots inside square roots. Whereas if this were a sort of problem you could do using a sum or difference formula, you would get a slightly different looking but mathematically equivalent answer. Okay, so that is just using a half angle formula to find a trig value of a given numerical angle. So now let's do an example where we have a quadrant and a trig value. Okay, so let's suppose the secant of alpha is negative 5/4. And alpha is between pi and 3 pi over 2. So we could write the problem this way, or equivalently, I could say that alpha is in the third quadrant. Okay, so it's important to be able to, if you're given a problem where you're given the quadrant of an angle, be able to express that angle as an inequality. So again, quadrant 3 means we're between pi and 3 pi over 2. Okay, so now we want to find the sine of alpha over 2, the cosine of alpha over 2, and the tangent of alpha over 2. Okay, this problem is made a little bit easier because we have the cosine of alpha, because it's the reciprocal of the secant. And we could actually use that to solve all of this, but I'm going to use a different formula for the tangent just so we can practice finding other trig values of angles. Okay, so for the sine, And the sine of alpha over 2 is again going to be plus or minus, and I'll just leave a box there. And it's going to be plus or minus 1 minus cosine of alpha divided by 2. And the cosine of alpha over 2, I'll do sine and cosine to start. Okay, that's going to be plus or minus the square root of 1 plus cosine alpha over 2. So those are our formulas we're going to use. So we need to know two things. We need to know cosine of alpha, and we need to know if this is going to be a positive or negative square root. Okay, well, the first part is pretty straightforward. What's cosine alpha? Well, it's going to be the reciprocal of secant alpha. So secant alpha is negative 5/4, and therefore cosine is negative 4/5. Okay, so we end up with plus or minus the square root of 1 plus 4/5 over 2 for sine, and plus or minus the square root of 1 minus 4/5 for cosine. So we can simplify that. That's an arithmetic problem. Now let's see what quadrant we're going to be in. So again, we want to figure out, is the sine of alpha over 2 positive or negative? Is the cosine positive or negative? And we can use the fact that alpha is in the third quadrant. So alpha is between pi and 3 pi over 2. If we take this inequality and we divide everything through by 2, this inequality is still true, and we get that alpha over 2 is between pi over 2 and 3 pi over 4. Okay, so alpha over 2 has to be somewhere in here. It has to be between 90 and 135 degrees, which means alpha over 2 is in the second quadrant. Okay, therefore, the sine of alpha over 2 is positive, and the cosine is negative. So now we can just go ahead and continue to simplify. So when we do the sine of alpha over 2, that's going to be the positive square root of, and following the same example that we used last time, we can simplify this fraction by multiplying the top and bottom by 5. So if we do that, we'll have up top 1 plus 4/5 times 5 is 5 plus 4 over 10. Okay, 5 times 5 plus 4/5 times 5 is 5 plus 4, which is 9. So we have the square root of 9/10, or 3 over the square root of 10. And then if we wanted to rationalize the denominator, that would be 3 root 10 over 10. Similarly for cosine, we're going to have negative the square root of 1 minus 4/5. And again, if we multiply the top and bottom by 5 to simplify, we're going to have 5 minus 4 over 10. So that's going to be negative the square root of 1/10, or negative 1 over the square root of 10. And if we want to rationalize the denominator, that's negative square root of 10 over 10. Okay, so that's sine and cosine. If we wanted to, we could do sine divided by cosine and get the tangent. And that's probably how I would do this problem if I were not working through this to show you how the formulas work. Note that sine over cosine should be 3 over root 10 divided by negative 1 over root 10 is negative 3. Instead, let's use one of our tangent formulas. And again, this is just for teaching purposes, just so we actually have to find a trig value of alpha. So I will use my preferred tangent formula. Tangent alpha over 2 equals 1 minus cosine alpha over sine alpha. And we'll remember that cosine alpha is -4/5. So now we have to find sine alpha. And we will use the fact that, so now we're looking at alpha, not alpha over 2. We use the fact that alpha is in the third quadrant, is between pi and 3 pi over 2, and the secant is -5/4. Okay, so our hypotenuse will have length 5. Our x will be -4, so secant is 5/-4. And then our opposite side, our y, using Pythagorean triples, is -3. And therefore, the sine of alpha is -3/5 y/r. Okay, and just like before, we can simplify this by multiplying the top and bottom by 5. So that's going to give us 5 plus 4 over -3, or 9 over -3 is -3. Okay, so again, if I were just doing this problem on an exam or something, if I were taking this course, I would not use the tangent formula. I would just do sine over cosine. But I did want to illustrate, sometimes we do need to find trig values of our angle alpha so that we can find the trig values of alpha over 2 using our right triangle. Okay, so that's going to be all for this video. In the next one, we will talk about our last set of formulas.